So last week we looked at Pythagorean theorem, which is something that I think for most people is pretty easy. So that allows us to find the lengths of all the sides of a triangle, assuming we know two sides and it's also a right angle triangle. In this lesson, we're going to look at SOHCAHTOA, or we're going to look at the sine, cosine, and tangent ratios, which will allow us to calculate either an angle in that triangle or one of the missing sides, provided we're given one of the angles. So by the end of this lesson, you should be able to state the three trig ratios. You will not be given them in a formula sheet. You are expected to memorize the three of them. You'll be able to determine the right ratio for the problem, and you'll be able to solve for an unknown side using the correct ratio. Our next lesson will look at how we find the angle, which I think typically people find easier, but maybe it's just that this lesson refreshes your memory. So the first thing we need to know how to do this section is we need to be able to label our triangle. So in this particular diagram, we have a right angle is listed, and we need to be able to label the sides. So we already know one of our sides. So based on Pythagorean theorem, we have learned that the side opposite of the right angle is called our hypotenuse. Now I will often use maybe the letter H or HYP, just simply to abbreviate because I'm not a great speller. And sometimes words like hypotenuse give me trouble. There it is. I'm already losing out Y's. So I'll often use H or HYP just to be able to give myself enough of a memory jog to remember which one is which. Knowing how to label a triangle will be important. Now we need to label the two legs. Now in Pythagorean theorem, we called them A and B, and it didn't matter which one we called which, but for sine and cosine, it's going to be important to properly label them. We're not going to use A and B. We're going to use the words opposite and adjacent. Now the word opposite is fairly straightforward. It's going to be opposite of something. So what we do is we look at our angle that we have information about or we want to find information about. So this angle has the letter theta inside of it, which means it's going to be the angle that we're interested in. The right angle will only ever be used to find our hypotenuse. So this angle is the angle from which we're going to label our opposite and our adjacent. So what side or what leg is opposite of this angle? Well, let's use, I often draw arrows. Draw a straight line until you hit the wall that's opposite. So this wall, this is our opposite side. Again, if I'm abbreviating, I'll often use O or OPP. That's all I need. Now the word adjacent means next to. So adjacent to what? Well, it's going to be adjacent to the angle that we want information about or we're given information about. So again, back to here, here's our angle. What side of the triangle is adjacent? Well, the hypotenuse is adjacent, but it already has a special name. So that means the adjacent side is this bottom edge. All right, so there's our adjacent, and I'll often use A or ADJ, just in abbreviating. So labeling your triangle is going to matter for us, is going to be quite important. Now, if instead I was talking about the angle up here, that's going to change our opposite and adjacent completely. So we have to think about what angle am I starting from? And from that angle, where's the opposite side and where's the adjacent side? The hypotenuse will be the same no matter which angle you're calculating. All right, so labeling our triangle, we're going to get some practice doing that as we go through our lesson. So there are three ratios. So I'm going to look at how these ratios come in, and I'm going to just use single letters in order to abbreviate our sides. So the sine ratio on your calculator is abbreviated as sin. So sine, sin, you take a look on your calculator. We'll look at our calculator in a second. And the abbreviation we use, we said the sine ratio is SOH. Well, what does SOH mean? Well, the sine ratio gives us the relationship, so the S stands for sine, gives us the relationship between the opposite side and the hypotenuse. So up here in this picture, this is our angle, you'll see the little arc in here. That means this is the angle that is our subject. I'm not sure what's happening here. Just give me a moment while my computer decides to catch up with me. There we go. I think we're good. So this is the angle that is our subject or that we're interested in. So this side over here, this is our opposite side, and this is our hypotenuse. I'm just going to pause recording for a moment and we'll come back just in a second. I'm going to see if I can speed up my computer. It's a little glitchy in here, my apologies. My computer decided to do a restart or restart some programs on me spontaneously, so I'm not sure what's going on with that. Fingers crossed we'll get through this quite quickly. So we're going to look at the sine, cosine, and tangent ratio. So the sine ratio is on your calculator represented by sin. Call it sine. I know a lot of students, they'll say sin. It's sine, even though math may sometimes feel like a sin. All right. So it's the sine ratio. And we use the abbreviation SO in order to remember what ratio or what side relationship that happens to be. So if we look at the letters, S stands for sine, O stands for opposite, H stands for hypotenuse. So the way this works, if we look at our picture, here is our angle that's the subject or the angle that we're interested in. The sine ratio is used to relate the opposite side to the hypotenuse. Now, if you see SOH, just write, I should have left a little more space here, I suppose. The sine ratio, so the sine of an angle, and we often use theta to represent our angle, is equal to the opposite side. So the first one goes on the top, it's our numerator, divided by hypotenuse. So that's what our relationship is. So the sine of a function, the number that we get if we take the sine of an angle, is the ratio of the opposite side to the hypotenuse. And you'll see that's drawn in our diagram. Now the cosine ratio, we use it like the sine ratio. On our calculator, it's cos. And the abbreviation we use for what it represents is ca. So we've got so, and then we've got ca. Ca, C-A-H. The C stands for cos. So cosine of an angle is equal to A as our adjacent divided by the hypotenuse. And then the last ratio that we have is our tangent ratio. So here's the angle that we're interested in. You'll notice the tangent ratio does not include the hypotenuse. It's the relationship between the adjacent side and the opposite side. So the tangent ratio on your calculator will be tan, and we use TOA to represent it as a ratio. So the tan of an angle is equal to opposite to adjacent, or opposite over adjacent. You have to make sure you match those orders or you won't get the right angles, okay? So those are our three trig functions. We'll look at using them a little bit as we go. SOHCAHTOA is the acronym that's often used to remember them. So just simply, it's just the ratio, sine opposite over hypotenuse. So cosine adjacent over hypotenuse, and then TOA, tangent is opposite over adjacent. Now, there are a couple other things that people have used to remember them. Some people do SOHCAHTOA. So some people remember it as some old hippie. That's how you spell hippie. Caught another hippie. Tripping on acid. I'll give you that one because if you forget SOHCAHTOA, that's one that for some reason sticks. I learned that in a grade 10 math class on PEI. We won't say which school that came from. I did a double take when I learned that one, but you know what? Nobody forgot it. So there's another one, Three Oaks, the famous one they use is old houses always have old attics. So your sign ratio is first. Old houses is your O and your H. Always have, that's your adjacent and hypotenuse for cosine. Old attics is your TOA. SOHCAHTOA is the one that I've remembered the most, so I will typically refer to it as that because I think that's the most common one. But if that doesn't stick with you and you need another silly acronym, there's several out there. All right, let's get to, I think we should be up just about to some calculations here. First thing we need to do, we need to make sure you know how to use your calculator. The most complicated part of this is when people in a class have different calculators and they're trying to figure it out. So first of all, we want to check that your calculator is in degree mode. Now, this is the calculator that I happen to have, so I'm very familiar with it. To check if it's in degree mode, you're going to be looking up at the top here of your calculator, if you happen to have this one, and there's often maybe a little D, or you could see on your calculator DEG. You want it in degree mode. The other options you could say is it could say G for gradient and R for radian or grad or rad are the other two things that you may see. Now, how do you, if it's not in degree mode, how do you put it into degree mode? Depending on your calculator, there's a couple different ways to do it. What might be easiest is just to put your calculator model in Google and double check. Now, for this particular calculator, to put it in degree mode, we have to press, you're going to press mode until it says degree, rad, and grad. So I think, let me just check here. I pressed it 1, 2, 3, 4 times. So for this particular calculator, press that button, the mode button, until it says degree, grad, or rad, and then you just select the number, press the number that corresponds with degree, which is 1. Some calculators have a button that's DRG. You'll want to press that, but if you have that on your calculator, you'll want to press that until your calculator shows D or degree for degree mode. If you're not in degree mode, your answers are all going to be incorrect. Okay, there's multiple ways to SOHCAHTOA only works if we're in degree mode. So in order to check, are you in degree mode? If you're not sure, easiest way to check is we're going to evaluate a couple expressions here. So sine of 45. If you're working on a calculator like this one, you will first press the sine button and then key in 45. So your calculator should say sine, I wish that showed out. Your calculator will say sine of 45. So you're going to press sine first and then 45. If your calculator does not have 2 lines for a display, you will do 45 and then press sine. So there's two options. So for some calculators, you'll press sine and then 45 and then equals, or that's, I call it a frontwards calculator. You put it in the way you read it. Or for a calculator that doesn't have the 2 lines display, press 45 and then sine and then equals. Okay, if you do that, I actually pre-calculated these so I don't have to calculate them again. Sine of 45 is a ratio that you will probably become quite familiar with. I know it's one that Andy has memorized off the top of his head because it's a common ratio. The sine of 45 is 0.7071. Okay, we're going to keep 4 decimal places because if we were converting this back to the angle, we would need the precision of at least 4 decimal places. If you round it off to 1 decimal place, the inverse sine of 0.7 is going to give us a much different angle. It's not going to be as accurate. So when you're finding these, putting sine of 45 in your calculator, try to get in the habit of keeping 4 decimal places. I meant to change this one instead of 135. We'll get to when we have 135. I want you to figure out the cosine of 35. So the cosine of 35, again, putting it in your calculator the same way, First type and press cos and then 45. If you're in degree mode, you'll get 0.8192. And then for tangent, you are going to get 5.6713. Again, for this type, keep the decimals. That's going to be important for us. We want to make sure we keep our decimals. Now, one more calculator check. This one you're going to use today. The next calculator check we're going to use in our next lesson, which you may end up doing today as well. But if you happen to forget, pop back to this lesson. So the next calculator check is, when we know what the angle is, it's easy to figure out what the ratio is. You just type it in. But what about when we want to undo sine and we want to figure out, well, what angle would give us 0.5? So in order to do these ones, we need to do the inverse sine. So our angle is going to be equal to the inverse sine. And if I write it like this, it might help you find it on your calculator, of 0.5. How do we type that into our calculator? Anytime you're looking for an angle, it doesn't matter which calculator you have. I don't think there's an exception out there. We are going to use the shift button, because you'll see the shift button here is yellow lettering, and you will see above sine, there is the sine -1, and it's in yellow as well. Your calculator, it might be a slightly different color, but you usually will see above the sine and cosines and tangent, there will be cos -1, sine -1. Now, if you're using your phone for a calculator, that could be problematic for you. As long as you have a calculator like this one, you'll be able to figure it out. There's a couple other ways that it can be written. Sometimes it's written as a sine, or arc sine. Usually we'll see it written as sine -1. So if you can put this in your calculator, right? So for the frontwards calculator, I'll write this sequence up here. You're going to do shift. Okay, then you're going to press sine. And in some calculators, it'll actually type in, you'll see sine -1 show up on your screen, and then you're going to put 0.5, and then your equals. Now, if you do that, you will get the angle is equal to 30 degrees. Okay, pretty straightforward. If you have a backwards calculator, you will put in 0.5. I guess that's not one button. I'm not going to put all the keystrokes in. Then you will press shift, and then you will press sine. Again, doing it in the backwards to the way that it's been written. And it should give you 30 degrees. If you're in degree mode, it will always give you degrees. So if you're doing cosine, the cosine, what angle would give us 0.7071? Well, the angle is going to be equal to the cos -1, the inverse cos of 0.7071. And that happens to be 45 degrees. Now, this is a great spot to do a little check. Well, what if we just rounded it off to 0.7? Would it make that much difference? And I'm going to put it in my calculator here just to give you an example. If we put in 0.7, it gives us 45.5 degrees. So we're half a degree off. You start multiplying half degrees off over a long distance, and being out by a half a degree can make a big difference. So it is important to make sure you keep those extra little decimals. All right. And then when we get to our tangent ratio, same kind of scenario where angle is equal to the inverse tan of whatever our number was, whatever our ratio was, 0.0451. Now, I'll remind you of how to do these ones when we get there in our next lesson. And this one gives us 46 degrees. So just making sure you know how to put things in your calculator. A couple little things. Now that we've done that, I want you to, before we do any calculations, I want you to stop and think. This is a good problem solving. What possible values could the ratios have? Now, if you've done calculus or pre-calculus, you would have thought about maybe limits on functions. It's been a long time since I've thought about limits on functions, but that's what this relates to. So what's the biggest value that sine could have? The sine ratio could be? What's the smallest value it could be? Well, if we look at this particular triangle, the sine ratio is always the opposite side divided by the hypotenuse. Now, what do you know about the hypotenuse? It's always the longest side. So if the hypotenuse is always bigger than the opposite side, this ratio will always be less than 1. Okay? Will always be less than 1. If you want to do a check, try telling me what angle. Let me do this just for the fun of it. Sine of an angle is equal to 1.5. What angle would you need? Put it in your calculator. So what I want you to do is, okay, let's say we said the sine ratio is 1.5. What do you see if you try to calculate that? Well, the angle is equal to the inverse sine of 1.5. And if you put that in your calculator, so let's plug it in. I'm going to put it in. I know what it's going to say, but I'm going to put it in anyway, just to prove what it's going to say. Not that you can even see what I'm doing, but hopefully you'll take a second to put it in. So shift sine and 1.5 equals. My calculator, I don't know if you can see if I put it up here. You can read backwards. You can see that. It says math error. So your calculator, if you do this, will give you an error. And that's because the sine ratio, in the sine ratio, if the hypotenuse is always the biggest side, a smaller number divided by a bigger number will always give a ratio less than 1. So that can't exist. It's impossible for it to happen. Cosine, let's look at that one. So cosine is A over H. So adjacent over hypotenuse. Hypotenuse is the longest side again. So since the hypotenuse is always the longest side, no exceptions, this ratio is always less than 1. No exceptions. Cosine ratio, if you have a cosine ratio that's greater than 1, or if you get that error in your calculator, you've made a mistake. Go back and check to see, did you label your triangle right? Tangent, on the other hand, is opposite over adjacent. Is the opposite side always the shortest? There's no rule for that. Is the adjacent always the longest? Not necessarily. Sometimes they could flip. One of them isn't always the longest side. So for tangent, you can get any value. Okay? You can get any value at all. It's just sine and cosine that will always be less than 1. We will eventually look at putting these on a graph, and I'll show you from a graph what they happen to be. We'll graph the function, but we don't need to do that for this section. That kind of comes after, just before we do our vectors. All right, let's do a few questions. We're going to start with a question. We're not going to calculate this one. All we're going to do is figure out which ratio we need to use. How do you do that? Well, the first thing I always do, because I flip things around, I still will typically write SOHCAHTOA on the top of my page. Now for me, I know I have a slight dyslexia, so I flip lefts and rights. By writing down SOHCAHTOA, I'm more likely to get my opposite and adjacents or in the right places. I'm sine and cosine, I never make mistakes of, but tangent, I always have to stop and think about. Maybe that's just me. Hopefully that helps you as well. But if it doesn't, that's one of my little strategies that I use. So what ratio is required to solve this? Well, if we look at this triangle, the first thing we need to do is we need to identify our sides. So this is our subject angle. Here's our right angle. So, okay, there's our hypotenuse. That's the easy one to find. So here's my subject angle. To get to x, x is not next to it, it's across from it. So this is our opposite side. Which ratio uses opposite and hypotenuse? Well, we look through our list. There's only 2 that use hypotenuse, sine or cosine. Sine has opposite and it has hypotenuse. So this one would be solved using the sine ratio. We're not going to calculate it. We're just listing. If I had to, what would I use? For the next one, okay, here's our right angle. There's my hypotenuse. I don't even care about the hypotenuse though, so it doesn't really matter. It just maybe helps me eliminate the other ones. So I don't need hypotenuse. So if I don't need hypotenuse, which ratio am I going to use? Well, if I don't need hypotenuse, tangent is the only ratio that doesn't use hypotenuse. Let's label our other two sides though. So there's my subject angle. And next to or adjacent to is 15. So this is my adjacent side. And then across from or opposite is x. The only ratio that uses opposite and adjacent is tangent. I'm just using process of elimination. No big fancy strategies, things that I guarantee you guys have used on multiple choice tests before. When you get stuck with something, you go through what are the options, use the same strategy when you're going through SOHCAHTOA, figuring out which angles to use. All right, let's actually do a calculation. Again, I'm not telling you which ratios to use because I think it's good to get used to right from the start picking out which ratio you need. That way, if you get a question and you're not sure how to solve it, you can always identify the ratio. So first thing we're going to do in every single case is we're going to label our sides. So here's my right angle. This is my hypotenuse. I'm just going to use a single h. The angle, that's my subject angle, is 40 degrees and x is opposite it. And we don't have an x on this side, so we don't really care about that side. You can label it as adjacent if you want. If you didn't label it, that would be okay. So what ratio do we need to use? Well, if we look at our ratios, we have a hypotenuse. I want the opposite. So what links opposite and hypotenuse together? Well, that happens to be our sine ratio. It's the only one that has opposite and hypotenuse. So let's write that out. The sine ratio says the sine of an angle is equal to opposite over hypotenuse. Now, I don't know who spent all their time figuring these ratios out, but I'm curious as to who would actually, maybe I just don't love math enough. I like math, but maybe I don't like it enough to sit and just compare triangle sides. So the sine of an angle, in this case, we have 40 degrees, is equal to the opposite side is x divided by the hypotenuse, which is 8. Whatever units you have for one of the sides, you will get the same units out for the other side. The units always have to be the same top and bottom. So what is x? Well, in order to get x alone, using our algebra, multiply by both sides by 8, we cancel out. So 8 times the sine of 40 equals x. Putting that in your calculator, and you can calculate them out separately. Remember, if you put sine of 40 in your calculator, keep 4 decimal places, you will get x is equal to 5.14 centimeters, or we could say 5 centimeters equals x. And I'm just kind of matching the units and the decimal places of what I have in the diagram. It's pretty straightforward. A little bit of algebra, pretty simple algebra for rearranging. If you get a little stuck on rearranging these, you should be able to do them because we did that little algebra review. We did them fine. But if you get stuck on it, put a 1 under your cosine of theta and think of it as rearranging a ratio. All right, next example. We want to calculate the length of side AB. So side AB, I've got an X in here already, but that's just a geometry way of saying the length of this line between those 2 points, starting at A and going over to B. Excuse me. So what is that ratio? Well, let's first of all label our sides. So my hypotenuse is here, but you'll notice it's not an X and we don't have a value for it. So we're not really interested in it at this point, but we'll label it just in case. We know the angle at point C. That's our subject angle. So let's label our opposite and adjacent. 9 is next to C, so it's going to be our adjacent. Opposite of 50 is X, so there's our opposite side. Which ratio uses opposite and adjacent? If you need to, write it down. If you write it down every time through this lesson, I guarantee you, if you don't have it memorized, you will by the end. I will not give you these on a test. Tangent is the one that uses opposite and adjacent. So the tan of an angle is equal to opposite over adjacent. Let's put in our information. Tan of 50 is equal to, the opposite side is X over adjacent, which is 9. Rearranging it, multiply both sides by 9. X is equal to 9 times the tan of 50. 9 times the tan of 50 will give you 10.7 centimeters. Get pretty easy algebra. The hardest part of these is simply just picking out which ratio, and people who get stuck on picking out the ratios and putting the numbers in typically are the same people that forgot to label their triangle. So that's why I'm taking the time to make sure we label our triangle. One more example before we finish off this lesson. I want to calculate the length of the hypotenuse in this triangle. First of all, where is the hypotenuse? So there's no X in this one, so we have to actually look at the words to figure out what we're calculating. The hypotenuse is there. Now let's label our other sides. So here's our subject angle. 12 centimeters is next to it, so this is my adjacent. The opposite, we don't even need to label it because we don't really care about it. We're not looking for it, it's not given to us. So if we look at SOHCAHTOA, which ratio relates hypotenuse to the adjacent? Well, if we look, sine uses hypotenuse, but it's linked with opposite or O. Cosine uses adjacent and hypotenuse. That's the right ratio. So cosine of an angle is equal to A is first, so adjacent on the top, hypotenuse on the bottom. And yes, I revert to top and bottom all the time rather than numerator and denominator. It's probably not very, some people would say it's probably not a good shortcut to do, but it works for us and it gives good results. So we'll leave that for now. Let's put the numbers in. So the cosine of our angle, cosine of 20 degrees, is equal to adjacent, which is 12 centimeters, over the hypotenuse, which is, we'll call it X. You could call it H if you wanted to. Maybe I'll put an X over here so that's clear which side is my X. X is on the bottom, not on the top. So this is what, remember back when we were doing our algebra, I said this is the kind that people make mistakes on. When X is on the bottom, if you remember, these two end up trading places. Now, if you don't believe me, put it over 1 and do a little rearranging. You will find that X is going to be equal to 12 divided by cos 20. Try it if you don't believe me. They will always end up trading places. Okay? So we put that in our calculator and solve. And when you put that in your calculator and you solve for the value of X, we get 12.8 centimeters. Well, if we kind of think about it, 20 degrees is a very small angle. I can visualize 20 degrees. This is not drawn to scale, but somewhere's close. And the smaller the angle, the smaller this side gets, the closer the hypotenuse and the adjacent side would get to being equal lengths. So that's why we get 12.8 centimeters. So lastly, just to summarize, and this is going to help us with our next lesson too, how do you pick which ratio? You've got 3 ratios, we're throwing them into a funnel, which one do we choose? Well, pick the ratio that has the side you want and the side you want and a side that you have. So think about which 2 sides am I interested in? What do I have information about, or what do I want information about? And that will help you determine whether you need sine, cosine, or tangent, make sure you label the sides first. If you haven't labeled your sides, you are more likely to make a mistake. All it takes is you don't have to write a lot. H-O and A, 3 letters. And just by quickly labeling those sides, it can help you out. And that finishes off this lesson. We'll quickly look at how to figure out angles next, and then we'll have our little trig section done, but it's not gone because the rest of the course uses our trig ratios over and over and over again. So make sure that you understand what it is that I'm getting you to figure out.